Alright, so we're going to pick up where we left off in the last video with our drag and drop flat list. So where we got to is we set up a pan responder which listens to touch events. And then we also set up an animated view which we basically position the animated view wherever our touch is being positioned. So what I mean by that is when I click on 4, it's going to follow my cursor now along with that. So notice it has 3 here, and for example if I click on 6 it has 3. So what we want to do is, depending on the cell that we click, we want the item to show up here to be different. And so we need to basically identify which index has been selected. And the information that we are given is a Y value. So we need to somehow determine the position or the index given a Y value on the screen. So there's a few things we have to take into account. First, we have to take into account how much the user has actually scrolled. And I guess scrolling is disabled. There we go. Actually, I want to do that real quick. So you'll notice once I start dragging, it doesn't go away when I stop. And that's because we haven't created a reset. So we're going to create a reset function here, and it's going to say this.setState dragging false. And we can call reset whenever it's released or when it's terminated. So now what we're going to get is when we drag and we let go, we should then be able to scroll again. And then also in our animated view here, we can only show this if we are dragging. Alright, so refresh. So it's going to pop up, and then when I let go, it disappears. So that view is going to come and go. Alright, so what I was saying is we need to keep track of how far we've scrolled. So that's one parameter. We can get that by listening to the flat list when it scrolls. So I'm going to say on scroll. And we can just console log the event. And as we scroll, you can see, first off, a ton of values get shown there. So if I say scroll threshold or throttle, we can basically set this to a number, and this will slow down the number of on-scroll events that get called. So I'm going to set mine to 16 so we just don't get as many events. And the events, you'll notice the thing that we care about is the content size height. So this is how far basically we have scrolled. So as we scroll, you'll notice the height, or actually I guess the content size is the entire height. The content offset is how far we are within that. So 1500, I scroll some, we're now at 4000. All right, so e.nativeEvent.content offset. So e.nativeEvent.content offset.y. So this is going to be the scroll offset, and we're going to store this in just a value up here. So scroll offset is 0, and then we can set it to this value as scrolling happens. Alright. The other thing that could affect things is if our scroll list is at the very, our scroll list is at the very top, but determining how far away from the top it is. So for example, our flat list could be rendered in the middle of the screen. So what we want to do is get how far away it is from the top. We can do that by saying on layout. And we're going to just console.log e again, and we can see when this is called. Just going to restart this so it clears. And we're just going to rebundle this. And so here we can see there's a native event. We can see the layout, and we can see the Y. So here we can see it's starting at Y0. Here, whenever I click on this, it's now starting at Y65. So it looks like it does change kind of in the middle. It's kind of a bit odd. I think I want this position absolute that may help us out here. So it's at 0, and yep, now it's going to stay at 0. So you can see our layout for the flat list stays at a y of 0. This is something you can add to your calculation though, in case your flat list was rendered below the y. So here I'm just going to call this flat list top offset. And we're just going to get that y position. The other thing we need to know is how tall each cell is. So in this case, I'm not sure the best way to go about doing this, but the one way that I did was on our render item here. I said on layout, and we can get this event, and that'll tell us the height. So here it's layouting out a few items, and we can see it has a layout of 65. So native event layout height. So that'll give us the row height. So we can create a variable called row height up here. And so now we have these variables. Whenever we start dragging here, we can actually determine the dragging index. And so we can store that in our state. And so by default, I'm going to just set it to -1. And then I'm also going to store the current IDX in a variable. We'll set it to -1 by default. So I'm going to say this dot current IDX is equal to some number like 5, and then we're going to set that in our state as well as the dragging index. Okay, so how we're going to compute this value here is we basically want to see how much we've scrolled. So this dot scroll offset, and we're going to add that to the y value. And then we want to subtract if there's any offset from the top. And then we're just going to divide that by the height of our rows. So this dot row height. And then I'm going to floor the value. And that will give us the current index of where it is at. Now I'm going to actually stick this into a function because we're going to use this in the future. So I'm going to say y to index. And y is going to be a number. And I'm going to put this. And now we're going to put y here. And we can call this function passing in our gesture state 0. So here we're going to say this dot y to index. All right, so let's see if this works. The other thing forgot to add to this is this is going to go past 0 or past the end of our list. So we want to kind of clamp it or restrict that. But let's just see if we're in the ballpark here. So if I click on, I guess we don't have any console log for this. But what we can do is now we are setting the dragging index. So down here, when we set render item, we can do the dragging index. All right, so here, when I click on 7, we see 7. When I click on 6, we see 6, and so on. So awesome. So now we get the exact value or the exact index that we want. Now, what I just talked about is making sure that we get 0. What we can do is we can say const value. And we're going to return value. And all we're going to say is if value is less than 0, return 0. If value is greater than this.state.data.length, return this.state.data.length -1, so we don't overflow. Right? So we're just making sure we don't go past the end of the length of the list and not below it. All right, so now we have this guy right here. The other thing that I want to do is whenever I start dragging this item, I want this to disappear or become white. So what I can do is in my render item here, I can say opacity. If the dragging index is equal to the index, and that gets passed into our render item, then we want the opacity to be 0, otherwise we want it to be 1. So what does that get us? So now when I click this, you'll notice we now have a white square there. If I go here to 4, it now has that. Here it is that. You also notice when I don't click away, or when I click away it becomes white. So when I reset, say dragging IDX -1. Alright, and when we let go, it goes back. There we go. Sweet. So really the next step I would say is when I'm scrolling this, well, the other thing is you'll notice when I click, it kind of gets it below. Like that's kind of far away from our initial tab value. So if we could get it closer. I'm not sure actually why it is so far away, because if we go to our animated view, we're passing the top in here. Okay, it actually is pretty close. Actually, it gets close whenever we start moving it. So what we could do, and it's complaining about that, I'm just going to say index -1 there. So what we could do is for the... I think what we need to do is we need to send an event for when it first starts moving. So I'm going to copy what we have here. And I'm going to set the current Y value is equal to Y0 here. So now when I click this, now it's right next to it. The other thing we could do is we could do row height divided by 2. And that will get us even closer. So now when I click, you'll notice my cursor is actually right on it. So click, and we're right on it. The other thing that we can do is we don't really want to listen for dragging the panhandlers whenever we render this animated view. So here I can say true, and we can set the value here that says like no pan responder, which defaults to false. And then we can say no pan responder. We want to do that, which is just an empty object we're going to spread. Otherwise, we do the handlers. All right, and then we can just drag this guy around wherever we want. So the next step with this is when I drag here, I want the list to rearrange itself. So what we're going to do is we are going to basically listen or watch for the changes in the Y direction. And when this moves into another cell, we then need to update the data. So how do we go about listening or viewing the Y value? So what we're going to do is we are going to set the current Y value. So I'm going to say current Y is equal to 0. You can set the this.current Y is equal to gesture state.y 0. And then whenever it's moved, we're going to update that. So now we have in a variable the current position of Y. The next thing what we're going to do is create a function here called animateList. And I'm just going to call this whenever the state has updated here. So I can be sure that the state has updated in a second function that I can pass in as a parameter. So this callback gets called whenever the state has been updated in the view. So here I'm going to say this.animateList. And so what animateList is going to do is it's going to recursively call itself. And we are going to do that inside of a request animation frame. And this way it is at least, we're not overloading the JS, I'm not sure what you would call it, but basically I guess the JS thread. And so we're going to stick it in here, and then we're going to call animateList. So here's where we're going to check Y value, see if we need to reorder. So this is the part which is my guess adds some latency and some lag into things, because we're basically just recursively checking this, and we can set a variable up here called active false, and we're going to say this.active is true. And then when we reset, we can set active to false. So then in our animate list here, we can say if not, or we can just do it at the top here. If it's not active, return. So this is our condition to stop recursing. So here now we're going to check the Y value. And so what we're going to do is we're going to see if that Y value is in a new index. All right, so we're going to say const new index is equal to this dot Y to index, and we're going to pass in the current Y value. And this is why I set the current index here, because I can compare what the new index is to the current index. So I can say if this dot current index does not equal the new index, we can update the state. And we can say this dot current index is now equal to the new index. So basically we want to call a reorder function. And this reorder function sets the this dot state. Actually, here we go. We're going to pass in the data, the old index, which is really the current index, so maybe you want to do this afterwards. And we're going to move it to the new index. So where can we get this reorder function? Well, I just went to Stack Overflow and copied to one. There's probably an npm package you can do as well. So I went to Stack Overflow and found a immutable move function. So I'm going to copy this. I'll link it below if you want to copy as well. And I'm just going to put it up here. And we'll call the immutable move. All right, so if we've detected a new index, aka we have moved in the Y direction into a new cell, what we want to do is we want to update the data. All right, let's see if this actually works. So here I'm going to add a console log that says reordering. All right, so I click this. Nothing should happen right away, and then as I go to here, it should say reordering, and now you can see the 6 is kind of following us around, right? That's kind of cool. Now, you'll notice the white space kind of just sat there. So what we want to do is we're going to say the new dragging index is going to be, well, I guess we don't want to change the dragging index. I was thinking that we want to set the dragging index equal to the new IDX, but I don't think that'll work. Because now you see the thing that we are hovering is changing. But you know what? This is actually right. We do want to update the dragging index. But down here when we're rendering the item, instead of passing the dragging IDX, we really want to be passing what that value is in the data. So it really should be that. So now when I move this around, that's exactly what I want. So now when I pick up 2 and I move it around, we can see as I move into other people's cells, it reorders the list, and the white place follows this around. And then when I let go, the item snaps into place. So cool. I think that is basically how we want to do drag and dropping. At least this is the simple version of it. There's really one other thing to this, and that is when you get to the end of a list, I want it to keep scrolling. Like notice when 33, I want to change it with the next number, it won't let me. So it won't let me scroll. It should also be able to scroll up. So that's what I'm going to talk a little bit about in the next video, is how we can get the flat list to scroll. But I hope this gave you a good idea of how we can use basically the offsets and the positioning to figure out the indexes, and then we basically listen for the values to change, the Y value to change, and then we reorder the list accordingly. Now again, this version is super laggy on Android. As you can see, it actually looks pretty nice on iOS, or at least it's pretty smooth on iOS, at least the emulator anyway. There's a few things that I was able to do. One, I added pure component and I put it in production mode instead of development mode. That helped a lot. And now I'm also playing with the reanimated library, which I think looks a lot better than using the request animation frame. So I think that may be able to speed it up. So those are a few things that may be coming into the future to make this an even better implementation. But that is it for this video.